Can you hear me now? I was on mute. Thank you, Satyajit, for mentioning this. You should be able to hear me now. Let me know if you still cannot. Thank you for letting me know. Awesome, awesome. So I was just saying hello and welcome to the fifth edition of Learning Python, a Java developer learning Python. The goal of these live streams is to document the entire process of a typical Java developer taking on the task of learning Python all live, entirely live, right? It's not like I'm going to go end the live stream and go do some Python work. I all my Python learning is going to be on camera, and the hope I hope the benefit of this is you folks can follow along and learn with me. Think of it as the combined study classes that we used to have back in school. I don't know if you've done it. We used to do this a lot. Like friends and I had to prepare for the exams, right? Friends and I would gather together and study together, right? And share each other's learnings, help each other, and learn and try to do well in the exam as a group, as a group of friends, okay, as a community. That's the goal. I hope you will join on this journey. I have already completed 4 sessions of live streams. All 4 of them are available in the playlist provided in the description of this video. So if you haven't seen the previous ones, please check them out as well. I have also provided a GitHub repo, both in the chat and also in the description of this video. This is where I will continue to check in stuff as I work on it so that you can check out and follow along. You can pull the changes and follow along. Every time I commit, as you're watching this, you can immediately, every time I commit and push, you can pull and you can continue to follow along. Some quick logistics about the setup that we have in case you haven't attended the previous sessions. We have, give me a second. Our coding environment is Visual Studio Code. Okay, so this is my VS Code window, and I have 2 directories here. One is tutorial experiments. What we're doing is we are looking at the official Python docs to learn from it. Okay, no courses, no books, none of the other stuff. We are looking at the official docs and seeing how much we can learn from that before we hit some kind of a roadblock and go, okay, we need like a course or a book. So far, we've been doing okay, been able to learn from the docs, and we're able to understand and put those things here. As I understand the concepts, I also verbalize it, I say it out loud. So in case you're having trouble, you can, see if my train of thought helps. Um, the tutorial experiments are things we do as we learn from the docs. We go and we write code to verify whether what the doc says is correct or not. The exercises are where we actually do hands-on coding. Okay, we pick a problem. We in fact ask our good friend ChatGPT to suggest Python programming challenges, and it gives us something, and then we try and implement it. Right. So we have 5 problems covered so far, starting from the very basic, just print a greeting, all the way to a word count calculator. And each of these programs have like the exercise details and the comments at the top, and then the code that I have written below. Okay, so similarly here, exercise details at the top, and then the code below. So all of this stuff has been done live. So if you want to catch this, you can go watch the previous streams. As far as the progress of the learning is concerned, we covered up to classes. Okay, we've covered errors and exceptions. We covered the first 8 modules of this um, this material, right? The Python material, and now today we are going to be starting very exciting. We're going to be starting classes, right? Before we start classes, though, I want to write some code to make sure I haven't forgotten all the things that I've learned. So we're going to do some exercises. And this is something that I always stress when you're learning a programming language or you're learning a framework. It's not enough to just read the documentation or maybe do some simple exercises. You want to start with a problem. Okay. You want to ask your friends or chat GPT or your teacher, say, give me some problems where I can implement whatever I've learned so far and test my understanding. Okay, it's not like, okay, I'm learning classes, I'm going to write a piece of code which creates a class. No, you're going to start with a problem and then go, okay, I have to use classes for this, and then you're going to apply it, right? Applied knowledge is what you're practicing as well. So we're going to do that now by asking ChatGPT to give us a few more questions, a few more problems for us to solve. Maybe we will do like two problems and then we'll dive into classes. How does that sound? All right. Okay. So I'm going to ask ChatGPT to suggest. So here is the prompt that I had earlier, and it gave pretty decent responses. It's basically generate three programming exercises for a beginner Python developer, which I am. So that worked okay. So I'm going to say the same thing. I'm going to do two because we're going to do two exercises today. Beginner Python developer, which um, tests understanding of what are the things we learned. We learned exceptions and input output. I'm going to skip input output because that's basically just string manipulation. We learned modules, exceptions, and modules. All right, we'll do two. And it looks like I've got ChatGPT confused. All right, it took its time, but then it did okay. All right, two exercises to understand exceptions and modules. First one is write a Python program that prompts the user to input two numbers, then divides the first number by the second number and prints the result. Your program should use a try except block to handle the case where a user tries to divide by zero. The user enters something that's not a number. Your program should print a friendly error message. Okay, so ask two numbers and divide by zero. This is very similar to the calculator thing, so I might ask it to provide one more because we kind of did very similar stuff with the calculator. Random choice. Python's random module has a function called choice that selects a random element from a list. Write a program that uses this function to simulate a dice roll. Your program should first prompt the user to enter the number of sides in the dice, and it should use a choice to select a random number between 1 and the number of sides and print. The program should handle the case where the user enters something that's not a number. Well, this is not quite module. Okay, so I'm not very happy with both the suggestions. So I'm going to ask it to do again, and I'm going to be a little more clear. I'm going to say understanding of exceptions and um, creating modules to be used in other modules. That's what we want. We want to be able to test our understanding of creating modules. Importing is very easy. If somebody else has created a module, you just import it and you use it. That's we've done that before. But how about creating? Let's try this one. Man, this thing is fixated on divide by zero. It seems to be saying the same thing. You see that? Okay, well, I'm at least going to do the module thing. Create a Python module called math operations that contain functions add, subtract, multiply, and divide. Again, this is very similar to what we did. Each function should take two parameters, perform the relevant operation, and return the result. The divide function should use exception handling to return a user-friendly error message if the second parameter is a zero. Create a Python script that imports math operation module. The script should ask the input and call each of those four functions in math operation. Each number as parameters. It should print the result. Okay. It's doing pretty much the same thing. I think I'll have to leave it in memory so that I can ask it to suggest something else. It seems like resubmitting it is getting it back to the calculator. Can you suggest two more exercises, please? reading and writing from a file. This is good. We can test our understanding of file as well. Okay. And then create a custom exception. We haven't done classes, but I think it should be easy to create a custom exception. Okay, let's do these two. Okay, let's do these two. So this one's reading and writing from a file. Okay, and it looks like it hasn't created a module exercise, but that's fine. We can just live with that for now. So I'm going to create a new file, and this is going to be 06 file read write.py. We're going to write this code. What is it supposed to do? Let's read here because it's easier. Write a Python program that allows the user to create diary entries and save them to a file named diary.txt. Each entry should have a timestamp attached to it to show when the entry was made. The program should also allow users to read all the entries from the file. This will help you understand how to work with files, which is a common task in many real-world programming situations. Okay, this seems like a good one. And I think for this one, I'm tempted to use JSON because, we are going to be adding diary entries. So it's going to be like, save some amount of diary entries. You need to save the date as well. And then you extract it. And then you add another diary entry and then save it back. So you need structured data. It's not just about text. So I was thinking, well, why don't we use JSON? And we've learned how to do JSON in the previous stream, right? How to read and write JSON. This is supported kind of using the JSON library. You can do import of JSON, and then you can do JSON.dump, okay, which basically puts something to a file. You have JSON.dump_s, which converts it into a string, and you can write that to a file if you want. But this one's shorter. You can do JSON.dump, and it saves it to the file. So let's use this and write the simple program for diary entries. Okay. So I'm going to create a function called read diary entry. And then this is going to use the read operation, which is this one. Okay. I'm going to have a file name is going to be an empty string to begin with. And then I'm going to ask print input diary file name. And then I will have file name equals input. I don't need this then, do I? I'm going to ask for it, get the input, and now I will pass this to the read. Read diary entry is going to take a file name. Is it str? Yeah, it's str. Read diary entry is going to take a file name and it is going to read from it and return a JSON. Okay, so here, I guess I'm doing errors anyway here, so this is going to handle exceptions as well. What I need to do is get the file, read the file from the file name, and if what happens. So there are a bunch of questions in my mind now. What happens if the file is empty? Okay, if the file is empty, then does this throw an exception or does it just return an empty object? What if the file doesn't exist? I'm guessing that throws an exception here, right? So what I'm going to do is first check if the file exists. Is there a way to check if a file exists? Let's find out. Python check if file exists. Is file. os.path module. Import os.path os.path.is file. Okay. So here I can do that, put it inside a loop so that it constantly checks for it. right? It makes sure that um, all of the input is available, right? The file is available. So I'm going to say while true, you do the input, and then, or maybe I can move this here. File name is an empty string, and then while, what was that? os.path.useFile. So I'm going to import os.path, and then while imported as path, and then I'm going to do while path dot is file of file name, while not path dot is file of file name. I'm going to get the path and then keep asking for it until they enter a proper path, right? Now here, they can, if they don't want to do it, they can just press Control C and then they quit. Then that's fine. Okay, but I'm gonna keep asking them to do this until they give us a proper path. Once I have the file path, now I can do a read diary entry. Now I know that this file exists. I say read diary entry of file name. Okay, and I'm going to test. I'm going to test a couple of things. First, I'm going to test what happens if the file is empty. Does it throw an exception? If it does, we're going to have to catch it. So I'm going to first run this. I have to import JSON as well. Okay, so this is imported. It loads to this file. Okay, do I need encoding? I thought it was accepting encoding as an argument. Looks like it doesn't. Interesting. Okay, we'll deal with that afterwards. Now we want to make sure that it at least reads something. So I'm going to create a new file here called diary.txt. Okay, empty file. And I'm going to run this one. Python 06. Okay, so get an error here. JSON load of file name. Why is it complaining? Attribute str object has no attribute read. Is it because that thing is empty? Let's try with a JSON object and see if it's any different. No, it does seem to fail. Str object has no attribute read. JSON.load of file underscore name. So it's gone through this while loop. It's got the input and it's verified that this thing is a valid file. And now it's failing when I do this. So we got to figure out why. Str object has no attribute read. It's happening on JSON.load. Let's take a look at JSON.load again. What is it doing? To decode an object again, if f is, oh, that's not what I want. This is not load. Okay, hang on. I think I'm using a different API. JSON.dump gets the text. To decode an object again, if f is binary or text file, which needs to be open for reading, JSON.load of f. Okay, JSON files must be encoded in UTF-8. I think let's look at the documentation for JSON.load. I feel like I might have to pass in something more. JSON.load a file object. It takes a file object as a parameter. It's not okay. That's the problem. So I'm gonna have to open it and then pass it to JSON.load. Fair enough. I'm going to say file equals open of file underscore name, and then here is where encoding shows up. Yeah, encoding is UTF-8, and then I pass file to JSON.load. Okay, so it seems to have worked fine. I'm going to clear this out as well. I'm going to clear diary because I want to make sure this works fine with an empty file. Let's print this. Okay, so it is, it needs a value. It needs a value, otherwise it doesn't work. So here's what I'm going to do. I'm going to put this over here, and then if file dot, is there a, basically looking for a length, right? Buffer file no. I remember seeing the file length somewhere over here. After read of size is going to give the size. Read line. Okay, so I don't think I have an API to check for the size of this file. It's back to Google. os.stat is going to give us the file size. Okay, here's something I can do. I think I can kind of get two birds with one stone here. There are two reasons why there would be an exception with getting the value from JSON. First is the file is empty, or second is if the file has invalid JSON, right? The JSON is not proper, in which case as well, I feel like it would throw an error. So I'm going to catch JSON decode error over here and then just return an empty string or an empty JSON and just blow away the existing file. Okay, so it's like if it's a bad file, it's basically just going to clear it out. So I'm going to try doing this, and then here I'm going to add an except when there is a JSON decode error. I'm going to do have to import this. Okay, it's coming from JSON. Okay, if there is a JSON decode error, I'm going to return an empty object, right? I need to return an empty dict, which is going to be this. All right, let's test this out now. Send the file name again, and I'm going to get an empty object. And now in this file, I'm going to maybe create an array. Okay, I'm going to create 1, 2, 3. It's a mixed array, and it still doesn't work. This should be valid JSON. Okay, let's do an object. It's not JavaScript, right? It is JSON. It has to be an object. What am I thinking? This is name foo. Okay, simple JSON. And we get back none. JSON.load. Oh, we have to return this. Ah, I'm basically going to return this. Okay, by pasting the incorrect one, we verified that the validation works as well. Okay, so it's got the JSON back, and if you don't have it, it returns an empty dict, which is what we want. Okay, now what do we need to do? So I'm going to write the diary entries and save them into a file called diary.txt. Each entry should have a timestamp attached to it to show when the entry was made. The program should also allow users to read all entries from the file. Okay, so now we have read the file itself. Now we can create like a loop of a menu, right? We can provide a menu. We say, okay, press 1 to read and print all the contents of the diary. Press 2 to enter a new diary entry, and press 3 to exit, something like that, right? So here I'm going to do a while true. I'm going to say print, and I'm going to use the triple quotes to enter a multi-line string as we did yesterday. I'm going to say choose the operation. One, to print all diary contents. Two is make a new diary entry. And three is going to be exit. Right? I will say choice. Menu choice equals 0. Okay, while menu choice is not equal to 3. I'm going to do this. And now here I'm going to read menu choice equals input. Okay, if input is not in, I don't think there's an is. Input not in. I'm writing English here, not Python. Input not in a list of all the operations. Right? I have 1, I have 2, and I have 3. Those are the 3 operations. If they don't exist over here, I'm going to just say continue. So it's going to go back and make a loop. Now we know that input is one of those 3. So here I'm going to do a switch, right? What's the syntax for switch? I have forgotten already. So let's look it up. Match. Okay, here it is. Match the variable and then the individual values. Okay, so match the variable, which is menu choice, and then I'm going to have the individual value. If it's 1, I'm going to wait. How does the indentation work? I have to say case. Case 1. What do I need to do? I need to print all the diary contents, right? So I'm going to just print. I'm just going to print the JSON as is now, and then we're going to format it a little bit afterwards. Okay, so I'm going to say diary contents equals this. And here I'm going to print diary contents. Okay, case 2, I'm going to print enter new diary entry, and new entry equals input. We're going to take the value that the user has entered, and then we are going to add an entry. So in order to add an entry, we need to have a list of entries, right? So here I'm going to have, instead of an empty JSON, I'm going to have entries colon, and it's an empty list. Does this work? Entries is not defined. Wait, I'm going to have to do quotes. Is it? So I want to initialize a dictionary where there is one key called entries, and the value is an empty array. Okay, empty list, so that I can push to it. Now here, once I get the new entry, I'm going to push diary contents dot entry. Diary contents is read diary entry, and I'm getting this. Okay. Entries dot push. What is it? Append. Dot append of new entry. And I'm going to write to the file as well. And this is where I had to use a with, right? I had to use a with here because this is not like I'm not closing the file. This is not good. So I'm going to go back here and use the with statement here. With. Okay, so here with open as f, which is what I want. Okay, so I'm going to use that here. With file open as file. All right, now I can do this, and I'm going to move this over here, right? It's going to give me pretty much the same thing, and I'm going to do that over here as well. So that's open and close the file, right? So here again, I'm going to open and close the file with pretty much the same thing, but this time I'm going to do a write operation. Okay, open, and then the second argument is going to be what type of operation we want to do. In this case, I want to do a write. So I believe the option is W. We can verify that with file with open, and yeah, W is the way to write to the file. Now I'm going to do json.dump. json.dump of the object and then the file. Of the diary contents and then the file. I think I'm spelling diary wrong and I'm confused. Hang on a second. is it DIARY is the... Okay, for a second I confused myself. I think this is good. So now with the file open, I'm going to dump the contents to the file. And now after that, I'm going to, what do I need to do? That's it, I'm done here, right? The only problem would be, I don't think you're gonna have an error over here for JSON, but we might have an error for the file. well, like it's not able to create that file. But we will see how that works. I'm going to do this, and then in the case of a case 3, I'm going to just do a continue. Okay, so since I have a continue here, I can get rid of this option here. Okay, I can get rid of this, and I can use the default. No, I'm going to quit break. There's going to be break, and then the default option is going to be continue. How do I do the default option? This is match. Case underscore. I think underscore is the wildcard. Okay, so I'm going to have a case underscore, and I'm going to say continue. Okay, does this look good? I don't know. We'll find out. We don't have any of the other stuff that we would like we don't have the timestamp, which is mentioned we need to add. So we're going to just verify that this works now, and then we will add the timestamp. Okay, so we got the menu here, and what are the contents right now? Oh, we've got foo, and it doesn't have anything, so I should do that. Okay, I'm gonna quit. I'm gonna press 3. Why is 3 not ending? 3 is exit. And when I say 3, I break. Oh, is it breaking the match and not? It might be breaking the match and not the while here. Okay. Okay, in which case I can, this can be gotten rid of because we already have the continue. If it's a 3, I'm going to end the application. There was a thing we did to end the application. Let's figure out what that is. I need to make a list of all these things because otherwise I will forget it. Let's ask Google again. Terminator script sys.exit. Okay, yeah, I remember now. We did sys and then try to exit from there. I import sys. Now here I do, in the case of 3, I do sys.exit. All right, let's test this out. Input the name of the file. It's going to be this. And now it should give us the empty file, the empty object with the entries. Okay, we needed that because we're going to be pushing entries to it. So now if I were to say print all the diary entries, it's going to say, okay, there's nothing. I'm going to say make a diary entry, and I'll say hello. And now if I print, I have hello. Make another diary entry, some gobbledygook, print. Now I have that as well. And when I press 3, it exits. Oh, the other thing I forgot to verify, which is if I enter something else, it keeps asking me. Okay, cool. This is what we wanted. Now, what we need to do is add the timestamp because that's one thing that we haven't done, right? So allows user to write the data entries, saves them to the file. I even asked them for an input, which is like, hey, better. Each entry should have a timestamp attached to it and to show when the entry was made. Should also allow the users to read. Okay. Okay, so we're going to add a timestamp now. And we're going to do this by, again, not having a string as an entry. We're going to have a dictionary as an entry. A dictionary is going to contain the text and the timestamp. So here, instead of a new entry, I'm going to say entry text is equal to input. And now I say new entry is going to be a dictionary of the entry text, which will be the entry text, and then the timestamp, which will be, how do you get the timestamp? Is it date? I don't know how to get the timestamp, so let's figure that out. Python get timestamp. Current timestamp time.time. Import time and then do time.time. Okay. And import time, and then the timestamp is going to be time.time. And now that is going to get saved. Okay. So let's try this again. Did we write to the file? Oh yeah, we did write to the file. Okay. So I'm going to remove this and make it an empty file. Now run this again. Diary.txt. Print all the contents, nothing here, right? Now I'm going to make an entry called hello world. And now it should contain hello world and the timestamp. And now I'm going to make one more, which is something else. It should contain that. And when I exit, it exits and it has all this data over here. One last thing I'm going to do is to display this in a nice format. So when I'm printing the diary contents, it doesn't look that good, right? So what I'm going to do is use the what's it called? The operator which the fancy operator in Python. Let's figure that out. List comprehension. This is the one. Okay. So I'm going to use this. Print. I'm going to have printable entries equals. I'm going to say oops, entry dot entry text for entry in. I'm going to get the values here, which is basically this stuff, read diary entry. I need to do that. Read diary entry of file name contents equals this, and then for each entry in, contents dot entries. Okay, contents of entries. So I'm going to get the array, which is the array of entries, and I'm just going to get the entry text for each of them. Okay, and I'm going to print entries. And then I'm going to print can I do this? Can I do that? I don't know. We'll find out. So basically I'm just doing that inside. So I'm not getting another one, right? I'm not holding on to a variable and then doing it. I'm basically just printing it right there, right here in the list comprehension. Instead of getting the value, I'm basically just printing it. I think it should work because what it needs is an expression, but we'll find out. Okay, so print all diary entries. Dict object has no attribute entry text. Okay, so I'm going to have to do this. I'm going to have to do this entry text. Right? I think so. Okay, there we go. So we get the entries. I'm going to say make a new diary entry and something else. And then now I say print all the entries and then just prints it in like a neat order. And even though it's saving the timestamp, it's not printing that over here. So yeah, so that's this one. I think we did a little bit of, did we even do exception handling? I think we did. I don't know. Let's find out. Yeah, I guess we kind of did. But this should kind of give us this our warm up for today. I have this. I'm going to save this here. I'm going to clear this out and say live stream. What is this? Are we on live stream 4 or 5? Which one are we doing? We are doing 5. Okay, live stream 5 warm up. Did this not get added? Uh-oh. Commit, staged, amend. Come on, come on, come on. Okay, and I'm going to push this out. All right, now we've got that, and now we are ready to move on to object-oriented programming in Python. Did you know that Python can do object-oriented programming? You probably knew it, and you're right. Python can do object-oriented programming. Let's figure out how it does it. Classes. Classes provide a means of bundling data and functionality together. Okay, creating a new class creates a new type of object, allowing new instances of that type to be made. Each class instance can have attribute attached to it for maintaining its state. Class instances can also have methods defined by the class for modifying its state. This seems to be similar to what we've learned so far, right? Compared to other programming languages, Python's class mechanisms adds classes with a minimum of new syntax and semantics. Interesting. It's a mixture of the class mechanisms found in C++ and Modula 3. I don't know about Modula 3, but I'm familiar with classes in C++. Python classes provide all the standard features of object-oriented programming. The class inheritance mechanism allows multiple base classes, and the derived class can override any method of its base class or classes. And a method can call the method of the base class with the same name. Okay. Objects can contain arbitrary amounts and kinds of data. As is true for modules, classes partake of the dynamic nature of Python. They're created at runtime and can be further modified after creation. Oh, so classes themselves can be further modified after creation. That's very interesting. In C++ terminology, normally class members, including the data members, are public, except see below private variables. And all member functions are virtual. As in Modula 3, there are no shorthands for referencing the object's members from its methods. A method function is declared with an explicit first argument representing the object, which is provided implicitly by the call. The method function is declared with an explicit first argument representing the object. Which object? This object, which is provided implicitly by the call. That's interesting. So it's like we have there's no difference, is what they're saying. There's no difference between how a member is declared and how a method is declared. And a method always has a first argument, which is the object itself. Okay, I think it'll probably make more sense once we see an example. Okay, where did we go? Where did we go? Okay. As in Smalltalk, classes themselves are objects. Okay. This provides semantics for importing and renaming. Unlike C++ and Modula 3, built in types can be used as base classes. Oh, thank you, Siri. As in Modula 3, there are no shorthands. Okay, here. Class members of data are public, except private variables, and all member functions are virtual. Okay. Okay, in Smalltalk, they're objects, semantics. Unlike C++ and Modula 3, built-in types can be used as base classes for extension by the user. Also, like in C++, most built-in operators with special syntax, arithmetic operators, subscripting, etc., can be redefined for class instances. Okay, it's kind of like overloading, right? You're overloading um, with the operators. It's impressive that you're learning in public as a way to keep you motivated to keep. That is true, and the goal is to motivate others as well. So you know, join the motivation and keep learning with me. It's a win-win. Lacking universally accepted terminology to talk about classes, we make occasional use of Smalltalk and C++ terms. I would use Modula 3 terms since its object-oriented semantics are closer to those of Python than C++, but I expect few readers have heard of it. Who's the I here? They started using I. Who's I? Is it Guido? Hi, Guido. A word about names and objects. Objects have individuality, and multiple names in multiple scopes can be bound to the same object. This is known as aliasing in other languages. This is usually not appreciated on first glance at Python and can be safely ignored when dealing with immutable basic types, numbers, strings, and tuples. However, aliasing has possibly surprising effects on the semantics of Python code involving mutable objects such as lists, dictionaries, and most other types. Wait, what is aliasing again? Objects have individuality, and multiple names in multiple scopes can be bound to the same object. Okay, so we've done aliasing in when we're importing modules, right? We were able to alias a module. We were able to alias something else that we imported, like a member variable that we imported from another module or another package. We were able to alias it. So I think that's what they're talking about here. Is you can alias, but it looks like there are benefits of that are a little more than just changing the name. Okay, so we'll figure it out. It can be safely ignored when dealing with immutable types, but it can have possibly surprising effect on mutables. We'll find out. This is usually used to the benefit of the program since aliases behave like pointers in some respects. For example, passing an object is cheap since only a pointer is passed by implementation. And if a function modifies the object passed as an argument, the caller will see the same, will see the change. This eliminates the need for two different arguments passing mechanisms as in Pascal. Okay, so it's passing references just like in Java, right? So it makes sense. It makes sense. So just to clarify, the whole pass by value, pass by reference argument, I'm not saying Java is pass by reference, period, right? Java is pass by value where the value is a reference. Okay? Okay. Um, it's a huge debate. Python scopes and namespaces. Before introducing classes, I'll first have to tell you something about Python's scope rules. Again, the I. Okay, Guido, please tell me. Class definitions play some neat tricks with namespaces, and you need to know how scopes and namespaces work to fully understand what's going on. Incidentally, knowledge about this subject is useful for any advanced Python programmer. Okay, let's begin with some definitions. A namespace is a mapping from names to objects. Most namespaces are currently implemented as Python dictionaries, but that's normally not noticeable in any way except for performance. So namespaces are mapping names to objects. It's kind of like the symbol table concept that we come to think of when we are looking at variables and scopes, right? So when you think of a bunch of variables and scopes, you have a mapping of the variable name to what the value is. In this case, it's mapping of names to objects, in which case I'm assuming it's references, but they don't answer that yet. So they're implemented as Python dictionaries, but that's normally not noticeable and it may change in the future. Okay. Examples of namespaces are the set of built-in names containing functions, such as ABS, and built-in exception names, the global names in a module, and the local names in a function invocation. Right. This kind of fits what I was intuitively thinking of. It's like the symbol table, then the variables and the symbols in the scope. In a sense, the set of attributes of an object is also form a namespace. Set of attributes of an object also form a namespace. Okay, fair enough. The important thing to know about namespaces is that there is absolutely no relation between names in different namespaces. For instance, two different modules may both define a function maximize without confusion. Users of the modules must prefix it with the module name. We kind of saw this when we created the same methods in two different modules, and we had to use aliases to either create a new name for the thing when they're trying to import the same thing, or use the module name dot in order to resolve the confusion because they both have the same name. Okay. By the way, I use the word attribute for any name following a dot. For example, in the expression z.real, real is the attribute of the object z. Strictly speaking, references to names in modules are attribute references. Okay? In the expression modname.funcName, modname is the module object and funcName is an attribute of it. In this case, there happens to be a straightforward mapping between the module's attributes and the global names defined in the module. They share the same namespace. Not sure I followed, so let's read that again. I use the word attribute for any name following a dot. Okay, so this could be a property of a class, which is what we are learning right now. It could be a variable in a module that we have imported, right? A variable or a function in a module that we have imported. That could be an attribute as well. Okay. Strictly speaking, references to names in modules are attribute references. The expression modname.funcName. Modname is a module object, function is an attribute. Okay. In this case, there happens to be a straightforward mapping between the module's attributes and the global names defined in the module. They share the same namespace. Okay, now I understand. Inside a module, the namespace of the module is going to be the same as the namespace of the global namespace, where we are basically importing it. Attributes may be read only or writable. In the latter case, assignment to attributes is possible. Module attributes are writable. You can write modname.theanswer equals 42. And we've already tried this. We imported a module attribute and we were able to change it. We were able to change the value that went into another module. Writable attributes may also be deleted with the del statement. Hey, kind of like JavaScript. For example, del modname.theanswer will remove the attribute the answer from the object named by modname. I'm guessing it is going to just remove it in this particular instance. It is not going to remove it for everybody else because it could potentially result in a problem. Let's test this out. I'm going to create a new folder here, and I'm going to call it module del testing.py. I didn't want to create a py here. Module del testing. I'm going to create a new file, which is the import.me.py. Okay, and inside import.me.py, I'm going to have foo equals 20, bar equals 30. Okay, so I have two variables. Now here I'm going to create a new file, which is a goodconsumer.py. And what this is going to do is it is going to import this, import me. Okay, and I'm going to print import me dot foo, and I'm going to print import me dot bar. Okay, and I'm going to put this in a method, def print all. Okay, and I'm going to create one more, which is bad consumer dot py. And what this is going to do is exactly the same as what good consumer does, but I'm going to tell import me dot foo. Okay, it's going to basically delete. Um, okay, you think it's going to delete for everybody? Well, we'll find out. We'll find out. It depends on how Python kind of shares that thing, because here, does it do it only once? It's importing from the same source, or every time I do an import, is it reading from the file? If it's reading from the file every time, then it's going to basically, it's going to have everyone is going to have its own copy. So I think that this will answer that question. Now I'm going to create a new file, which is test.py. I'm going to import good consumer. I'm going to import bad consumer. Okay. First, I'm going to do good consumer dot print all, just to make sure that this whole thing is working fine. Tutorial experiments. I'm going to say, let's save this. CD, what is this called? Module del testing, right? I'm going to say Python test.py. So it prints everything. Cool. Now what I'm going to do is do a bad consumer dot print all, right? Bad consumer is, true to its name, not very good, right? It's deleting stuff when it prints. So now the question, the mystery is, when good consumer gets to print, they're both importing from the same module. Bad consumer has gone and deleted what it imported. Now, is good consumer going to have both or not? Let me know in the chat what you think is going to happen. The person who gets it right is going to win a grand trip for two to Hawaii. If only. Get an error. Okay, so this is import me has no attribute foo. And where is this happening? This is happening in bad consumer. Oh man, I made a mistake. I made a mistake. This doesn't make sense at all. I need to remove this, right? Okay, so I'm gonna clear. Bad consumer deleted foo and was trying to print it, which doesn't make sense. So now the question is, does good consumer try and print it, and does it find that, or does it error out in the good consumer part? Let's test it. Okay, looks like good consumer doesn't get it as well. So looks like what's happening is, and a module has a single representation of an object in memory, right? Even if you have 10 different Python scripts importing from one file, they all share the same object. So if one of them messes with it, all the others see the impact, which is pretty interesting, right? This is true for even for writing. Like we were able to reach in and change the value. We didn't have to wait for Dell to do this. We could have tested this back then. What happens if I change an imported module? It changes it for everybody else who's importing it. Okay, cool. This is good to know. It isn't very straight, it isn't answered very clearly over here, so I'm glad I did this exercise. Where did we do del? Okay, here. We'll remove the attribute from the object named by mod name, and that object is one and it is shared. Namespaces are created at different moments and have different lifetimes. The namespace containing built in names are created when the Python interpreter starts up and is never deleted. The global namespace for a module is created when the module definition is read in. Global namespace for a module is created when the module definition is read in. That is like when the first import is encountered, I would assume. Normally, module namespaces also last until the interpreter quits. Okay. It's not very obvious that it is one per module. They should have added this over here. The statements are executed by top level invocation of the interpreter, either read from a script file or interactively, and are considered part of the module called underscore underscore main. So they have their own global namespace. The built-in names actually also live in a module called is called built-ins, and we've printed this earlier, and we should um, we tried to do this and like yeah, we were able to print the values. This should probably be bad practice. Imagine the chaos this could cause. Yeah, it's I think it depends. You can think of a module as kind of like a data holder. That's one use case where what I see of this. Okay, so imagine you have let's say diary, right? We did this exercise where we were managing diary entries. Imagine one Python file which just held the diary entries. Okay, and you had one file which was reading from it, another file which was writing to it. All of them could basically just update the contents of that variable in that one module, and you basically have global state now. Okay, this is one way of handling it. Generally, you're right. What they say is global state is bad. Anytime you have global state, you have no control over who is reading from it and who is writing to it. So essentially, you should pass those state parameters as arguments so that only the ones who need it get it and they can modify it, right? But this is one way in which we can potentially use global state. Perhaps it should be bad practice. You're right. Um, The local namespace of a function is created when the function is called and deleted when the function returns or raises an exception that is not handled within a function. So every time a function is called, it creates this function namespace, and when the function returns or raises, it removes it. Actually, forgetting would be a better way of describing what actually happens. Of course, recursive invocations each have their own local namespace. It's fine. It's very similar to scoping in Java, right? We use stacks for when you have methods which call other methods. Well, every time you create it, you enter a new method, you're creating the symbol table, the scope for it, and that scope gets pushed onto a stack. And when the method returns, it gets popped, right? It's very similar here. A scope is a textual region of a Python program where a namespace is directly accessible. Directly accessible here means that an unqualified reference to a name attempts to find the name in the namespace. Okay. Okay. It has to, when anytime you're calling a variable, call it foo, it goes and tries to access the immediate namespace. Fair enough. Although scopes are determined statically, they're used dynamically. At any time during execution, there are 3 or 4 nested scopes whose namespaces are directly accessible. The innermost scope, which is search first, which contain local names, the scopes of enclosing functions, which are searched starting with the nearest enclosing containing non-local but also non-global names. Okay. Next to last scope, which contains the current module's global names, and the outermost scope containing the built-in names. Okay, so when you're looking for a variable inside a method, inside a function, first it looks for the innermost scope, which is the local variables inside that method. Next, it is going to look for enclosing functions, starting with the nearer, but it is only for non-local. If it is local, it obviously finds it over here. right? And it finds it in the first step. So this is for when it doesn't find it in the first step, but also non-global. I don't know why non-global, because if there is a global variable and it finds it in the immediate enclosing function, doesn't it just take that? Does it say, okay, it's global, so I'm going to skip it. I'm only going to look at non-global. We're going to have to verify this because this one isn't very clear. The next to last scope contains the current module's global names, okay, which is the current module's global names is one below. It's not the last scope, apparently. The outermost scope is apparently the namespace containing built-in names. Okay, so it's like the built-in names is the global scope, and the module scope is below it. Below it are the functions nested one by one, and then the lowest is the scope of the function or the thing that is actually executing the code. Okay, clear so far? Let me know if you have any questions. This seems clear to me. So if you have any questions, let me know and we can kind of dive into it. If a name is declared global, then all references and assignments go directly to the next to last scope containing the module's global names. Okay, so it is not going to the topmost scope. The topmost scope cannot be touched, right? This is the namespace containing built-in names. This is Python's stuff. We are not touching it. When we create a variable in the module's global scope, it is going to this one here, the next to last. All right, it's going to this one. Okay. To rebind variables found outside the innermost scope, the non-local statement can be used. If not declared non-local, those variables are read-only. An attempt to write such a variable will simply create a new local variable with the innermost scope, leaving the identically named outer variable unchanged. I think we tackled this in like the very first stream or the second stream where we were able to say non-local and we were trying to figure out where each item goes. Okay, so let's actually verify this and make sure that our understanding is right. That's the best way to figure this out. So I'm going to create a new file and going to say scoping test.py. Okay, so we're going to have a global variable. I'm going to say foo equals 10. I'm going to have a def sample function, and here I'm going to say print of foo, and it is going to print. It should print the global value. So basically what it's doing is it's looking here, doesn't find it. It looks up to the module scope. This is second to last, right? It finds it there and it prints it. Now here I can say foo equals 20. And now what it's going to do is it's going to create a new local variable here called foo, and it is going to print that. And then the global value is still going to be 10, right? And if I were to print foo here, it'll still be 10, which is over here, because this one created a local scoped variable and it printed that here. Okay. In order to say go change this one itself, I need to say non-local foo, right? Shouldn't I do that? To rebind variables found outside the innermost scope, the non-local statement can be used. If declared non-local, those variables are read-only. Why would I need it if I'm already getting it? Maybe because I need this. Okay, so let's see. I'm going to do this and I'm going to print non-local foo. Does this work? Expected expression. Let's take a look at what non-local does, how it works. Non-local statement equals, maybe it has to be on the right hand side. Let's try this. I'm going to say bar equals non-local foo. No, that doesn't seem to work either. Expected expression. Non-local statement causes the listed identifiers to refer to the previously bound variables in the nearest enclosing scope, excluding globals. Names listed in a non-local statement must not collide with pre-existing bindings in the local scope. But that is, does it have to be before so that it doesn't confuse with this foo? Not sure I understand. Let's figure this out. Python non-local. So we have non-local name, and then we save the value, override it, and so I just have to declare it, and I'm not using it. Okay, like this. Do I do this? No binding for non-local foo found. Or does it have to be one more? Oh, and I hate this. Does it have to be? You should define another scope. Yeah. It has to be, it cannot change the one below, right? It has to be like a nested scope. So let's try that out. Yes, you're right. Let's do def inner function. And here I'm going to do non-local foo. Get rid of this. And here I'm going to print foo. And now here I'm going to execute inner function. So sample function is going to declare an inner function, execute it. And what is the inner function doing? It's saying, I want a foo which is non-local, which means that it's not going to look at this one. It's going to look at this one. Yeah? Is that the case? Let's see. It didn't work at all. What's happening here? And inner function print foo cannot access free variable foo from where it's not associated with the value in the enclosing scope. I'll put 30 here. This is super strange the way it's done. We're going to have to wrap our brains around this. So let's see what happened. So this worked. We were able to get 30, 20, and 10. Okay, so when this printed, it was 30. This printed, it was 20. And this printed, it was 10. So none of the values have changed, right? Like this is where the scope is supposed to be. So for example, I can remove this and it should still be the same, right? This is going to be 30 because it's inner, and then it's going to go here. This is going to be the scope inside this one, and then this is going to be the scope inside this one, right? I can change this and I'm going to get exact same output. So what exactly is non-local doing here? I don't know. I'm going to try one more with perhaps a website that doesn't bombard me with ads. Let's see. Let's see this one. Compare this without non-local. What's going on here? We have outer, there's a global X. We have an outer method, which has an X, and we have an inner, which has an X. Okay? It prints inner, it prints inside the inner, and it calls inner, and then it prints outer, which this is kind of what we've done, right? We've considered exactly the same thing. To this, using non-local where inners X is now also outers X. Now when you do non-local X and then you change the value, the inner, okay. So I did non-local foo and I changed the value. Perhaps that's because I had defined it outside. This is what's missing. Now I'm going to have to do this over here. I'm going to define a local variable over here, which is 20 in this scope, right? In the outer scope, I have defined a local foo. And now I go to an inner scope, and if I change this, like I don't have this, then This is going to refer to this one because it's bubbling up, right? I say foo equals 30 inside the inner function. It's going to go, is there a foo inside the inner function? No, there isn't. It's going to go one level up. It's going to say, is there a foo inside sample function? There is. So it is going to update that, right? Right? We'll see. Now, when we run this, it should print 30, 30, and 10. No, it's still printing this. Okay, wait. Inner x is now also outer x. Now, if you do, okay, I had to do non-local. I had to do non-local. Now, when I do non-local foo and say foo equals 30, then this is where the behavior will change, right? Now, what's going to happen is this is going to go, okay, I don't want a scope created, like I don't want foo created in this scope, in the inner function scope. I want you to go up. Now it'll print 30, 30, 10. Here's hoping. No, I didn't save it. There we go. We got it. All right, this requires an applause. So this was a little tricky, all right? So here's how I understand it. Without non-local, right? Every time you write to a variable, it is going to create that variable in the scope where it is being written. Okay, so here I have an outer module level foo. You have a inner sample function foo, and then I have an inner function foo. Okay, without non-local, this sample function foo is going to have a foo in its scope. The inner function foo is going to have another foo in its own scope. So when I print foo 30, it is foo of the inner function. When I come over here and print this, this is foo of the sample function. Now let's say I don't want this. I don't want this. I don't want it to create a new variable inside the scope of inner function. I want it to actually reach out and change what is in the outer function. So for that I do non-local foo. Okay, this is not a local foo. This is imported. This is from outside. Reach out and get the foo that's outside. So now when I do this, when I say foo equals 30, Python is not going to create a new foo inside the inner function. It is going to reach out and get the foo that was one level above, which is this. And so now when I say foo is 30, it's actually changing this foo because there is no foo in the inner function. And then when I print foo over here, it should print 30, which it does. Okay, so that's non-local. Okay. Right. You didn't yeah, I didn't add non-local in the inner function before, and it's like that's the key to identifying which one works. I was a little confused about what that thing is doing. Okay, cool. And this doesn't work for global, right? So for example, if I do non-local here, does it update 10? I don't think so. Oh, it has to go one level up. Now this is complaining because, oh, there is no foo over here. But let's verify this, okay? Let's verify this. Now this should be 30 or 2020. Is that the case, or will it fail? No, it's actually erroring out right here. It's saying no binding for non-local foo. Okay, so yeah, like we saw earlier, we cannot bind to the module level. Okay. So we covered this. We covered non-local. If not declared non-local, the variables are read-only. Okay. You simply create a new local variables in the innermost scope, leaving an identically named outer variable unchanged. Okay. Usually, the local scope references the local names of the textually correct function. Outside functions, the local scope references the same namespaces as the global scope. Local names, outside functions, local scope references the same namespace as the global scope. The module's namespace. Class definitions place yet another namespace in the local scope. Okay. If it is in a method, if it is in a function, it's going to use the function's local scope. If something is not in a function, a piece of code is not in a function, its scope is the module scope. We kind of figured this out intuitively, but it's good to clarify it. Okay, this is good. And it says classes add another layer of scope. Anytime you have a class, you get one more level of scope, right? So it says place yet another namespace in the local scope. Fair enough. It's important to realize that scopes are determined textually. The global scope of a function defined in a module is that module's namespace. Do you think this is useful in any way? Python is by default preventing the creation of closures. I don't think so. You can still have closures by reaching out to the parent, right? If you I think if you read only, then it is not going to create anything. So let's say I don't do non-local foo, right? And print I don't change the value of foo here. Okay. So when I just print foo, it is going to try and find foo in the inner function scope. If it doesn't find it, it should reach out to outer. So it should be you should technically have closure, right? Let's verify this. We'll do a closure verification as well. You see that? It did print 20. So 20 is closed. So um okay, I wasn't planning to do this, but let's verify closure as well. So now what I'm going to do is I'm going to return inner function from the sample function. Okay. So I'm going to say inner equals sample function, and I'm going to execute inner. Now when inner runs, it should print 20 because it is going over there, right? It's basically looking up over here. When this was created, foo was 20. Now I'm getting it out. Here there is no foo. This 20 is gone. This function is now over, but still inner should print 20, and it does. Okay, so we do have closures in Python. This is just a way for you to say, well, when I'm writing, I want to be able to reach out and write something else, right? By default, writing something in a function is going to create a new variable. This is the whole headache is because Python doesn't have var. Okay, imagine if it had var. So let's say it had var foo equals 20, and here you say var foo equals 30. Okay, this makes it very clear. It's saying you want a new variable called foo. Okay, and if you didn't have var, you go, okay, I want to modify what was in the previous scope. Var would have made it very clear, but Python doesn't have var, right? This An assignment is same as a declaration, so you have to have some way of distinguishing between, okay, this is a creation of a variable and assignment versus this is just getting what is already in the scope and assigning. So for that, by default, since var doesn't exist, it is going to create a new variable. So in order to say don't create a variable, you have to use this non-local circus to say don't create it. In this scope, when you say foo on the left hand side, I don't mean it to be creating a variable. Okay, that's what this is. Right. It kind of forces you to be intentional about closures. Could be a good thing. I don't know if it's intentional. Like, you get closures anyway. Like I said, even without non-local, you get closures. It's just, I think, a quirk of the syntax of Python where the declaration is the same as assignment. So you're gonna have to separate it somehow. Okay. Where did we end this? Okay, here. Global is in the module's namespace, no matter what. Okay, it's important to realize that scopes are determined textually. The global scope of a function defined in a module is that module's namespace, no matter from where or by what alias that function is called. Global scope of a function defined in a module is that module's namespace. I see. So if you were to take a function from a module, get it out of that module, put it into some other module as a variable and execute it, the global scope of that function is still the module. See, here is another closure, right? The scope of the module, the scope of the function is closed on the module. So no matter where you take that function, it is going to be it's going to hold on to all the scope in that thing. On the other hand, the actual search for names is done dynamically at runtime. However, the language definition is evolving towards static name resolution at compile time, so don't rely on dynamic name resolution. In fact, local variables are already determined statically. Talking about a change in the language, I'm going to skip this. I don't want to spend too much time doing this. It doesn't seem important, so I'm going to use my judgment and move on. A special quirk of Python is that if no global or non local statement is in effect, assignments to names always go into the innermost scope. Okay, assignments do not copy data, they just bind names to objects. This is true for deletions. The statement del x removes the binding of x from the namespace referenced by the local scope. Okay, in fact, all operations that introduce new names use a local scope. Well, this is what we found as well, right? Unless you have a non local, it is going to use a local scope. In particular, import statements and function definitions bind the module and function name in the local scope. Is global what that is? For the piece that we're missing, like we were trying to figure out how to get this, right? How to get the sample function to use this. Do we have to do global foo? Maybe that's what we need. And now you cannot do non-local here because there is nothing in this one. But now here, what do we expect? Going to I'm going to have to change this back to what it was before. Okay, so I'm going to have a local foo over here. And here I'm not going to have a local foo in sample function. I'm going to have a global foo. Basically, I'm saying sample function, don't create a foo, pick up what's in global. So it should ideally print, it prints this one, which is 30. It should print 20 and it should print 20. Okay, it should print 30, 20, 20 this time. And of course, I have to save it. Okay, it's printing 30, 20, 20. So when you're in the top level and you don't have a function scope and you're picking up the module scope, you're going to have to use the global keyword. If it's a function scope, you're going to have to use the non-local keyword. Okay. The global statement can be used to indicate a particular variable lives in the global scope and should be rebound there. Non-local indicates particular variables live in the enclosing scope and it should be rebound there. This should be very clear now. Okay. Scopes and namespace examples. This is an example demonstrating how to reference the different scopes and namespaces and how global and non-local affect variable binding. Well, we've already done this. We're going to move on. Note how local assignment, which is default, didn't change scope test binding of spam. Local assignment, which is a default, did not change the scope test binding of spam. Yeah, of course, because this is a local scope. Yeah, we already did this, buddy. Let's move on. First, look at classes. All right, classes, here we come. All right, we ready? Let's do the drum roll. Okay. First, look at classes. Classes introduce a little bit of new syntax, 3 new object types, and some new semantics. These guys boasted about making classes introduced into the language without many heavy semantics and it's very lightweight and all that stuff. And now they say a little bit of new syntax, 3 object types, and some new semantics. All right, let's see, Python. What have we got? You're talking to a Java developer who does classes day in and day out, right? So let's see if you're able to impress a Java developer in terms of how you build classes. Class name, colon, and then a list of statements. Oop in the chat. No, it's oops in the chat. You have to say, you have to, you have to add the S, otherwise it doesn't make any sense. Object-oriented programming, I don't know what S is for. Systems, oops. We are doing oops. Class definitions, like function definitions, def statements must be executed before they have any effect. Okay, it's like there is a parsing step where a class is being executed, class definition is being executed. You could conceivably place a class definition in a branch of an if statement or inside a function. So you're basically looking at inner classes here, right? Scoped classes. In practice, the statements inside a class definition will usually be function definitions, but other statements are allowed and sometimes useful. We'll come back to this later. It's almost like static blocks, right? Functions are the default, but there could be others. Excuse me. All right. So a function definition inside a class normally have a peculiar form of argument list dictated by the calling convention for methods. Again, this is explained later. Man, boy, I'm really looking forward to later. When a class definition is entered, a new namespace is created and used as the local scope. This is what they were hinting at earlier when they said when you're creating a class, it's basically going to create a new namespace, right? It's a new scope. In particular, function definitions bind the name of the new function here. Function definitions bind the name of the new function here. Are they talking about new as in a special new, as in a constructor, or are they talking about new functions? This is a little ambiguous. I guess we'll read on and it should clarify. When a class definition is left normally via the end, a class object is created. This is basically a wrapper around the contents of the namespace created by the class definition. We'll learn more about class objects in the next section. The original local scope, the one in effect just before the class definition was entered, is reinstated. Okay, so once your class is done, class definition is done, it goes back to the local scope wherever it was. If you're declaring a class, you're defining a class in a method, it's going to be the method scope. If it's in the top of the module, it's going to be the module global scope. And the class object is bound here to the class name given in the class definition header. Okay, so let's create a simple class and we will see what the class object looks like. Go here, tutorial examples. I'm going to create a new file, my class.py. Now here I'm going to class my class, right? And then here I can say foo equals 10. I can create a new member variable here and I can define a method print. I'm just going to call it my print because I don't want it to confuse with the default print. Or it should be fine because we're going to be referencing this by the class object name. I'm going to say print of from method. All right, here's my class. And now what this is saying is once the class is defined and the interpreter parses this, the name of the class is going to be created as a new symbol and the value of it is going to be the class object itself. There's going to be a class object. So I'm going to print my class and this should give me the class object, right? Let me remove this prompt because this is a little too much. Where did I print this here? This prompt is a little too long, so I'm going to shorten this. Okay, so what I want to do is see what this renders, right? So I'm going to do Python my class.py and see, I get a class object back, right? This is a class object. This is my class that was created. I'm not creating an object of my class, okay? By creating a class called my class, I created an object that is a class. Okay. Now I can create objects from that class, which are going to be separate objects. This object represents the class definition, not an instance. Okay, fair enough. Class objects support two kinds of operations: attribute references and instantiation. Attribute references use the standard syntax used for all attribute references in Python, object.name. Valid attribute names are all the names that were in the class's namespace when the class object was created. So the class definition looks like this. Okay, you have one member variable and one method. MyClass.I and MyClass.f are valid attribute references returning an integer and a function object respectively. Wait, so this is almost like a static, isn't it? When I do a MyClass.I, I'm getting which is it's not an instance. It is just I. Is that so? Let's find out. What happens if I do myClass.foo? If I print this, do I get 10? I get 10. So I here is like static. Okay, it's not a member variable, it's static, it's not an instance variable. I guess this having a myClass.print makes sense because it's like a method on it. But still, I having the value as static as a default is a little surprising. Okay, so when you do print, it's going to get the function and it's going to get the method. And when you do foo, it's literally getting the one instance. Class attributes can also be assigned. So you can change the value of my class of I by assignment dot by assignment. Doc, dunder doc is also a valid attribute, returning the doc string belonging to a simple example class. Okay, let's write the doc string. I'm going to say this is my first Python class. My first Python class. I'm so proud. I'm going to say print of my class dot doc, right? Dunder doc is going to give me this doc string, and I'm going to say my class dot foo equals 20, and then now I do my class dot foo. It should print the doc string, change the value to 20, and it should print 20. And it does. Okay, I'm with this so far. Class instantiation uses function notation. Just pretend that a class object is a parameterless function that returns a new instance of the class. Or there's no new keyword. You just do parentheses like this. Creates a new instance of the class and assigns it to a local variable x. The instantiation operator, calling the class object, creates an empty object. Many classes like to create objects with instances customized to a specific initial state. Therefore, a class may define a special method in it like this. So this is the constructor, Okay, so that's the constructor. And it looks like self is what creates member variables. By default, this is static. Self is what creates member variables. So I'm going to mess with that now. Okay, so I'm going to change this. I got this. Now I'm going to say x equals my class, and I'm going to print x dot foo. I'm guessing this is static, so it should again print 20. Okay, and I'm going to say x dot foo equals 30, and I'm going to again print my class dot foo. It should get updated to 30, just to make sure I got this and settled once and for all. Oh no, that's not what happened. What is happening here? Even if I changed x dot foo equals 30, this hasn't changed. This is still 20. Okay. Now x dot foo. Now if I were to print this, does it create a copy when I change it? So this is static. Okay, let's assume it's static. It printed foo from the class. Now I create a new instance and I change the value in that instance. Okay, before I change the value in the instance, it's still pointing to the It's still pointing to the static location. Now I change the value of the instance and I print it x.foo, and I get the updated value in the instance. But I go back to static and it still says that. So I'm guessing when you do x.foo, it's creating a new instance variable. Whereas if you don't do that, it goes back to static. Man, this is very confusing API design. Why did they do this? So by default, it's static. But then when you operate on that same variable as an instance, it creates an instance variable. Okay, this is different in Java because remember what happens in Java. When you have a static variable or a static method, it doesn't matter how you call it. You can call it as an instance, via an instance, or you can call it via the class. It is always going to point to static, right? Because it's defined as static, it's always static. But here, what it refers to depends on how you access it. You access as myclass.foo, it refers to the static variable. But you access it as an instance.foo, it's going to create an instance variable. It's not referring to the static anymore. So this is going to be some adjustment that we're going to have to do as Java developers. When looking at this, we go, okay, this is not quite what we expect when we're working with Java. This kind of weird as well, right? It's like you declare something, it's automatically going to become static. All right. I think self is the way you can force member variables, right? So this is the instantiation operator. This is the constructor that we are used to. Okay, I can define this special method, which is the dunder init, and I pass self, and it is going to use that. Now, when I'm saying x.foo, right now it is by default going to static, and it is getting. Let me get rid of all this other stuff because I know what's going on here. Let me get rid of this. So I print before assigning the instance variable, and I print after assigning the instance variable. I get rid of this. Now, you see, before assigning the instance variable, it uses what was here in the class. I haven't assigned anything to X. It uses what's in the class. But after assigning the instance variable, it gets that value. Okay, let me close the blinds here. I think the light is really hard. All right, now I'm going to initialize this in a constructor, and let's see if it can kind of force the instance variable. Okay, so I'm going to create a def init, was it? Yeah, init. And then I have to pass in self as an argument. You remember it's kind of like this, right? Anytime you pass a method, you will have to pass in, you'll have to accept that this, there is no implied this reference. There is a self and it gets passed in every time. Okay, this is called this in Java, and you don't have to pass it. It's implied. It's always there. Okay, yeah, a lot of different things compared to Java. Now I do self dot foo equals 20. Okay, now I have an instance variable called foo. Now, when I print my class dot foo, I'm going to get 10. And when I print x dot foo, I should get 20. Okay, I'm going to print my class dot foo. This should be 10. Create a new class called x, and I print x dot foo. This should be 20. Let's verify. Should return 10 and 20, and it does. Okay, so if you want to create a member variable in the class, you're going to have to do self dot. Fair enough. When the class defines an init method, the class instantiation automatically invokes the init for a newly created class instance. So in this example, a new instantiated instance can be obtained by new class. Of course, init method may have arguments for greater flexibility. In that case, the arguments for a given class instantiation operator are passed on to init. For example, what have we got here? We've got complex, and we've got two numbers passed to it. So the number of arguments is always going to be one lesser than the number of arguments in init, because it is always going to have a self which is not going to be passed in. When we are calling an instantiation of class, We have to just assume that that's going to get plugged in. Yeah, kind of weird, but we can live with it. All right, so I'm going to have init value. Okay, and I'm going to say new class of um, new class of 20, and it should print 20 again. New class of 100. It is basically I'm passing in a value and kind of having that be assigned, which is fine. Which is fine. Okay, and I use self dot for putting in the properties, right? It's like you get the value and then you can put in the properties. You can use this for copy constructor as well, I'd imagine. Instance objects. Now, what can we do with instance objects? That's a great question. The only operations understood by instance objects are attribute references. There are two kinds of valid attribute names: data attributes and methods. Data attributes correspond to instance variables in Smalltalk and to data members in C++. Data attributes need not be declared like local variables. They spring into existence when they're first assigned to. For example, x in my class, x is the instance of my class created above. Following piece of code will print the value 16 without leaving a trace. So I have x.counter equals 1, and I am, they're doing this, they're printing x.counter and then deleting x.counter. So I can create arbitrary variables here? Really? x.bar equals 100, print x.bar. Does this work? Okay, it is loosely structured. So it's kind of like JavaScript objects, right? JavaScript doesn't have like a fixed structure for classes. I think this is what they're referring to earlier, which is like class is kind of like a starting point, which you can set things up, but then it's not strict. You can remove things. They talked about del as well, right? So I can say del x dot foo, and then now I can print x itself. I don't know if there is a two-string implementation. Let's find out what this prints. This should print x dot is there attributes. I don't know if there is, but I'm not going to. Well, let's see. This is going to be my best guess at finding out whether attributes exist or not. Yeah, there we go. Dict gives us all the attributes of a class, and look at that. It's removed foo, and it has added bar. Interesting. It's completely transformed the class, the instance of the class itself. So it's no longer, even related to that class, at least the way it looks. Okay. The other kind of instance attributes reference is a method. A method is a function that belongs to an object. In Python, the term method is not unique to class instances. Other object types can have methods as well. For example, list objects have methods called append, insert, remove, sort, and so on. Well, that was because I assumed that list objects were objects. Maybe not. Well, they literally call it objects, right? So, okay, so maybe there are non-class objects, non-class instances. However, in the following discussion, we will use the term method exclusively to mean methods of class instance objects unless explicitly stated otherwise. Valid method names of an instance object depend on its class. By definition, all attributes of a class that are function objects define corresponding methods of its instance. Valid method names of an instance object depend on its class. By definition, all attributes of a class that are function objects define corresponding methods of its instance. So in our example, x.f is a valid method reference since myClass.f is a function, but x.i is not since myClass.i is not. Well, yeah. This makes sense, right? If a method is in a class, it is in an object. If the method is not in a class, it's not in the object that was created from that class. Unless somebody did a del. Can we del a method? Can we del a method? So we've got print, and let's actually print this thing, okay? I'm going to say x dot print, and then I'm going to del x dot print. Does this work? Print takes a positional argument, but no, wait. Print takes zero positional arguments, but one was given. What? Zero position arguments. Do I have to do self for everything? Really? My class has no attribute print. Okay, it looks like it works only for attributes and not for methods. All right, fair enough. You can't del methods. So methods at least, right? Attributes are like free form. You can add and remove stuff. At least methods are based on what's defined in the class and it doesn't change. Okay, cool. This is different from JavaScript. In JavaScript, you can put anything you want. Put a method, remove a method. You can do whatever the heck you want to your object, and JavaScript doesn't care. Okay. Method objects. Usually, a method is called right after it is bound. X.f. In this class example, this will return the string hello world. However, it's not necessary to call a method right away. X.f is a method object and can be stored away at a late or called at a later time. For example, xf is x.f and while true, it prints xf. Okay, so again, functions, methods as first class entities. You can assign a method to something else and call that method whenever you want. What exactly happens when a method is called? You may have noticed that x.f was called without an argument above, even though the function definition for f specifies an argument. That is self, right? Is this what f did? X.f. Where is f? What class is it talking about? Yeah, this is self. Yeah. Self is implied. You don't have to pass it. I got it, buddy. You may have noticed that x.f was called without an argument, even though function defines. All right, I have a comment here. Let's see. JavaScript does not allow accessing static class vars as instance vars. Python allows it until you write to it. Then it does not allow access to static var via the instance anymore. Yeah, it's kind of like shadowing, right? So when you create an instance variable, it's like both of them share the same space, right? You have different ways of accessing static vars versus instance vars in something like Java. But here, both of them share the same space. So by default, it is static when you declare it in a class. When you assign it with a self, it becomes instance. And from there, it's instance. And I'm assuming once you del the instance, it's going to go back to static. That's an assumption. So let's verify it. So here, I have I have foo, right? And I've got print x dot foo, and it is going to print 100. And I'm going to del x dot foo. And now if I were to print x dot foo, what do I get? Do I get 10? Yeah, looks like I get 10. So it's basically shadowing. You can still go back to static, but when you put an instance variable, it's going to look at the instance variable first. And if it doesn't find the instance variable, then it's going to go to static. All right. Okay, where were we? Yeah, surely Python raises an exception when a function that requires an argument is called without any, even if the argument isn't actually used. Actually, you may have guessed the answer. Yes, we did. The special thing about methods is that the instance object is always passed as the first argument of the function. In our example, the call x.f is exactly equivalent to myClass.f of x. In general, calling a method with a list of n arguments is equivalent to calling the corresponding function with an argument list that's created by inserting the method's instance object before the first argument. All right, with you so far. If you still don't understand how methods work, a look at implementation can perhaps clarify matters. When a non-data attribute of an instance is referenced, the instance's class is searched. If a non-data attribute of an instance is referenced, the instance's class is searched. If the name denotes a valid class attribute that is a function object, the method object is created by packing pointers to the instance object and the function object, just found together in an abstract object. This is the method object. What? If you still don't understand, I thought I understood and now I'm confused. Let's figure this out. When a non data attribute of an instance is referenced, non data attribute of an instance, it's like a method perhaps, the instance's class is searched. Okay? If the name denotes a valid class attribute that is a function object, the method object is created by packing pointers to the instance object and the function object just found together into an abstract object. This is the method object. So basically what it's saying is whenever I do, like I have print here, right? So whenever I use x dot print, okay, it's going to first see if there is an instance object. I'm not even going to do the parentheses, okay? X dot print, okay. First it knows this is non-data object. So it's going to go to the class and say, okay, there's no data object, data property called foo. There is, however, a method in that class. So what this is going to do is it's going to create a new method object, okay? It's going to create a method object, and it is going to be a combination of two things, is what it says. One is the instance, and the other is the function, right? The method object is created by packing pointers to the instance object and the function object itself together as an abstract object, okay? So x dot print over here is a combination object. It creates an object, right? If I say a equals x dot foo, okay, a is now a combined object of two things. One is the instance itself, which is x, and the other is the print method. Okay, so that is a. Now I have that combined object. That's the method object. Now when I call that method, basically what it's going to do is it's going to take that function, pass in the instance, because it has both, right? It's going to pass the instance to the function and then execute it. When the method object is called with an argument list, a new argument list is constructed from the instance object and the argument list, and the function object called with this is a new argument list. Okay, so that's fine. So when an argument is passed, it already has the instance. It's going to pass that as a first argument, and then it's going to pass the rest of the args as well after that. All right, now it makes perfect sense. Class and instance variables. Generally speaking, the instance variables are for data unique to each class, and instance variables are for data unique to each instance, and class variables are for attributes or methods shared by all instances of a class. Okay, fair enough. So this is a class variable. This is the static option that we are looking at. This is a class method. This is self dot, so it's an instance variable. Okay, we figured this out. As discussed in A Word About Names and Objects, shared data can have possibly surprising effects with involving mutable objects such as lists and dictionaries. Shared data can have possibly surprising effects with involving mutable objects and mutable objects such as lists and dictionaries. For example, the tricks list in the following code should not be used as a class variable because just a single list would be shared by all dog instances. Tricks is a list. Okay, and now we do init constructor. You're passing the name, you're putting it into a name which is an instance variable, which is fine. And here what I'm doing is self.tricks.append of trick. So in this case, it's actually using this. Interesting. Because I'm reading here. That's why. You see here, I'm not assigning to it. What you see here, self.tricks.append, is not assigning something to self.tricks. It's basically reading. And since I don't have anything assigned to self.tricks, when I just read self.tricks, what happens? It's going to go to the static, which is this one, right? Which is what happened here. When I did x.foo and I didn't assign anything, what was foo? Foo was the static, right? When I'm only reading without assigning, it's going to see if there is a self variable, it's an instance variable. If there isn't, it's going to go to static. So that's what's happening here, right? Self.tricks.append. You're saying self.tricks, but you're reading from it in order to append to it. When you read from it, it says, okay, do I have an instance variable? It doesn't find it. So it's going to go look up this thing and it's going to append to that. And yeah, no wonder all of the instances are writing to that same shared class variable, right? The way to break this is to put the self.tricks equals square brackets here, over here, right? Dog hive mind. Yes, that's this is a unintentional hive mind um, result. They all do the same tricks. What's going on? The correct design for a class should use an instance variable instead. Oh, there we go. Oh, they've done this in init, which is probably a better place for it, right? You instead of checking, oh, is it already there? If not, you do this. Well, put it once in init. The constructor's job, right? Don't put this guy here. Random remarks. If the same attribute name occurs in both an instance and in a class, then attribute lookup prioritizes the instance. If it's instance and a class, attribute lookup prioritizes the instance. Again, we have seen this, right? It's going to look at the instance. If it doesn't find it, then it's going to go for a class variable. Hang on, I'm getting a call. Let me respond this real quick. All right, is this clear? Any questions from the attendees so far? It seems simple enough. Okay. Data attributes may be referenced by methods as well as by ordinary users, clients of an object. In other words, classes are not usable to implement pure abstract data types. In fact, nothing in Python makes it possible to enforce data hiding. It's all based upon convention. Yeah, that's the thing. There's no private here, right? There's no data hiding. You have to basically just hope for the best, hope that nobody messes with your data. On the other hand, the Python implementation written in C can completely hide implementation details and control access to an object if necessary. This can be used by extensions to Python written in C. Huh. So it's not fixed. You can potentially change it as well by using extensions to Python. Who knew? Wow. Clients should use data attributes with care. Clients may mess up invariants maintained by the methods by stamping on their data attributes. Note that clients may add data attributes of their own to an instance without affecting the validity of methods as long as the name conflicts are avoided. Again, a naming convention can save a lot of headaches here. How about getting a private keyword? Python, huh? That would save a lot of headaches. Why don't you do that? You have to use extensions to Python written in C. That's why. Interesting. There's no shorthand for referencing data attributes or other methods from within methods. I find that this actually increases the readability of methods. There's no chance of confusing local variables and instance variables when glanced through a method. Okay. Often the first argument of a method is called self. There is nothing more. This is nothing more than a convention. The name self has absolutely no special meaning into Python. However, note, however, that by not following the convention, your code may be less readable to other Python programmers. And this is also conceivable that a class browser program might be written that relies on such a convention. Imagine writing other. That'd be fun, right? But yeah, this is self is a convention. Got it. Please use self. I'm not endorsing changing the name. Just messing around. Okay, any function that is a class attribute defines a method for instances of the class. It's not necessary that a function definition is textually enclosed in the class definition. Assigning assigning a function object to a local variable in a class is also okay. Love the series. Thank you so much, Deepak. Yes, please let me know how you find the series. We've made a lot of progress over the last 4 live streams. So yeah, please check it out and let me know in the comments. I'll look for your comment. Okay. Assigning a function object to a local variable in the class is also okay. Assigning a function object to a local variable. So I have a method here. It's a function object. The terminology is a little bit confusing because they say function object, but this is basically what in Java we call it a method, right? It's defined in the class definition, so it is a method, but this itself is a function. It becomes a method when, what, based on what they were talking earlier, it becomes a method object when you do instance dot the function. Then it becomes a method, right? So here I have a my class and I have print. So print is a function object, right? If I say, let's actually do this, get rid of this. If I say print my class dot foo, this should print a function object. And now if I say x equals new my class, create a new instance. I'm gonna have to create, oh, there's no new. There's no new here. I'm going to pass in a value which is 20. And now if I do x dot print, I'm not invoking it. I'm just getting that thing, right? This is print, not foo. Okay. I'm printing the print. This should be function. When I'm printing the x dot, this should be a method object, right? That's how it calls it. Yeah, you see this? This one's a function. And this one's a method, a bound method. And this is going to bind x and print together. So it's like a combined object which has those two. Fair enough. All right, following along so far. Now, F, G, and H are all attributes of class C that refer to function objects. And consequently, they are all methods of instances of C. Okay, they're referring to function objects. They're all methods of instances. Ah, you look at that. So now we have a method. The tutorial itself is confusing. Yeah, probably. If you're new to object oriented programming, I don't know. Maybe is it confusing because we're coming from a Java background? I don't know. Maybe people who have the first contact with object oriented might find this useful. I don't know. I don't have the context, so I don't know. But this does seem confusing to me. You're right. It is it's a little convoluted. Okay, so we have, what do we have here in class C? Okay, we have a function defined outside the class. Okay, now here I have a property of class C, which is a function value. This is still a function. It's not a method object, right? You get a method object only when you do an instance dot f, but we're not doing that yet. This is still a function. Def g, again a function. H equals g, again a function. So we have three function properties, f, g, and h on C. Let's okay, now f, g, and h are all attributes of class C that refer to function objects, okay? And they're consequently they are all methods of instances of C. Okay, h being exactly the equivalent to g. Note that this practice usually only serves to confuse the reader of a program. And this section only serves to confuse the reader of this documentation. Thank you so much for adding this here and confusing us. Methods may call other methods by using method attributes of the self argument. Methods may call other methods by using the method attributes of the self. So when you get self by default and you can call self dot, okay, fair enough. Again, just like Java, except that this isn't automatic, it is passed in and it's called self for conventional reasons. Methods may reference global names in the same way as ordinary functions. The global scope associated with a method is the module containing its definition. The global scope associated with a method is the module containing its definition. Okay, fine. Methods are going to have a global scope, which is where it's, which makes sense, which makes sense. A class is never used as the global scope. While one rarely encounters a good reason for using global data in a method, there are many legitimate uses of global scope. For one thing, functions and modules imported into the global scope can be used by methods, as well as functions and classes defined in it. Okay, this makes sense. So it would be like if you import something here, right? Import random. Now random is in the global scope. And now here I can print something from random, right? I can say f random dot random. Is that what it is? So yeah, so this is where I have a, this is a method scope, first of all. Like look at the levels here. So we have this scope, this is a method, sorry, this is a function, so it's defining a scope. And if it's trying to find something, if it doesn't find it, it's going to go to the class scope to see if it's there. If it doesn't find it, then it's going to go to the module scope, the global scope, to find it here, right? That's a good use case for a method trying to go to the global scope. All right. In the next section, we'll find some good reasons why a method would want to reference its own class. Each value in an object therefore has a class, also called its type. It is stored as object dot dunder dunder class. Okay, this is kind of like JavaScript. JavaScript has like a way to get the prototype from an object. So if I were to do, again, get rid of this stuff, I'm going to say X. Or actually, let me retain this. I'm going to say print X dot dunder. What was it called? Class. Okay. I'm going to initialize X to 20, and then I print this. It should print the class itself, which is main class. So this is the class object, right? Every time you create a class and it parses it, you get the class object. And the class object is assigned to the dunder dunder class property or attribute of the instance. So you can figure out what the instance is. All right. So with this, we conclude the initial part of object-oriented programming. I'm going to stop here because I'm feeling a little tired and hungry as well. So we've streamed for close to 2.5 hours. So I hope you found this useful. I'm going to try streaming again tomorrow. We're going to pick up object-oriented programming. We'll try and do some exercises as well. In the meantime, if you're watching the stream now or if you're watching the video later, if you have any specific questions or comments, feedback about how this is going, you want me to change the way things are done, or you have any questions that you didn't like, you didn't understand, or you want to cover something else, please let me know in the comments. I'm going to read the comments because this is like an ongoing series. I obviously cannot read all the comments of the hundreds of videos that I've already made, but since this is ongoing, I'm going to pay special attention. So please let me know in the comments what you want to be done and covered in the next live stream, and try and incorporate that. So thank you again for watching and joining me in this Python journey. um, See you, I think, tomorrow. I have a live stream set up tomorrow. Take a look at the playlist in the description. It should show all the other live streams that we have going on. And I hope to see you then. Bye bye.